Carlson's live podcast clips, episode 2.3. Yeah, just to shift a little bit here, we're about halfway time-wise. We talked about, or you wanted to talk about the airburst in southern Ohio.
Yeah, I just wanted to alert people to it. It is, I think it's 381, and that's on the cosmic tusk. I've got a paper, and this thing landed with absolutely no attention. So that's why I'd like to take the opportunity to, point it out and, get it on folks' radar that are communicating all this great information like you guys are. But if you go to the cosmic tusk, share mine, let's see.
Yeah, your website is listed in the description of every one of the Cosmographia Randall Carlson podcast.
Oh, I appreciate that. Okay, y'all see my screen? So 335 AD, they've identified preliminarily, I would say, not the full suite of testing, but certainly enough to publish that there may have been an airburst in Ohio at 335 AD. So, 1,700 or so years ago. And why is that significant? Well, first of all, the great hope of the Younger Dryas event, if you will, or people like me that believe it signifies something else with the Taurids, and as Randall does, that we, as all of y'all do, everybody on this call, thinks that there were repeated encounters with the Taurids, and there could have been encounters with other meteor streams that would have been catastrophic. But bottom line, things have happened over time, multiple times, with the Younger Dryas event being the big daddy, an order of magnitude larger.
Exactly.
And then that's right. And you don't have to go there. That's not proven yet. So we're stepping away from the Comet Research Group here, right? I am. But since I'm ball boy, I can do any damn thing I want, right? So Comet Research Group focused on the Younger Dryas event. Then they went to Tal el-Ammam, and that was, what would that be, 9,000 years later. But that's kind of it for airburst that the CRG at this point claims, because it takes so much work to nail one down. But the great hope is that people take these same tools, right? Forensic tools and approaches, right? And that they go, somebody will find that other stuff that guys on this call think is out there in time. And Ken Tankersley did it. Now, that said, Tankersley is a member of the Comet Research Group in good standing and a wonderful man. I've never met him in person, but I follow, everything he does. He's a great science communicator in Ohio. I think a beloved figure in Cincinnati. And his paleo site is Sheridan Cave in Ohio, which is a bone bed, kind of like Hall's Cave. Right, where it's accumulated, cave site with a bunch of great strata. And he's been on some TV, with Sheridan Cave, et cetera, showing the clear evidence that there were megafauna and then nothing. So that's his contribution to the Younger Dryas event. But then Ken, God bless him, he went out and dug in a mound and got samples from a Native American mound and looked for impact proxies, and he found them, and some of the geochemistry, right? So he's got, iridium anomalies, platinum anomalies, et cetera, and so forth. Spherules, there are friends, the spherules, the vesicular glass. And it's been a few weeks since I read it, and I'm not sure how he got to the date, but let's just say I believe it was, through associated carbon datable material at the same layer. Not exactly sure in the mound when it was, presumably at the beginning of the mound, but that kind of brings in a cultural thing. That's again saying that, wow, if you found that stuff and there's a mound there, there were people that witnessed it, that saw it. And how did that impact their culture? And how did they communicate in their myth and oral tradition subsequently to us? So it's fascinating. And you just hope that other people go out and do this.
And how close was that to, sorry, Russ, to Serpent Mound? How far away?
Hadn't looked. I'm not sure how far away it is. I actually have looked up the sites. He's got multiple, 11 Hopewell sites. Yeah.
Yeah.
And related proxies.
If there was some kind of common dating there. I haven't looked at the dating of the Serpent Mound in a while, but
it's pretty uncertain.
Yeah. But I think the work that they've done is somewhere around there.
Yeah. And then look at the nearby earthwork that seems to show either a weird kind of hair comb. Yeah, so maybe they were really into hair comb, some kind of comb.
It's like a broom star.
Or they were giving you the broom star. You can see the witch on it right there. We got too many questions.
About 20 years ago to kind of try to depict what I was envisioning may have been the event.
Yeah.
Probably multiple airbursts combined with ground impacts.
That's right. And I think we'll start finding evidence. So let's kind of think about it. You got the Younger Dryas event, and everybody that follows this stuff and our weird little world, they get that. Then you got Tel El Amam, right?
Mm-hmm.
And let's just say this is a little tiny blip, but you could probably do a full 125 page paper on these same sites. But let's say this is legit. It is legit, but it's just, it's a early indication. And then you have Atacama.
Mm-hmm.
So that's 4 airbursts right now.
Yeah.
Right. Nobody's even looking.
Right.
And it would be so cost effective for information obtained versus dollars spent. If you found key sites around the world, how about Göbekli Tepe, right? And just go see, do you find these types of materials and where are they in the record there? And Göbekli Tepe is special because there's no strata in the actual mound, but at the bottom of it, is there anything, beneath the material? Is there anything after you go subsurface, or just mixed into the material they buried it with, apparently? Are there any materials in there? And I've actually got hints they may be working on that. But the kind of thing that you want to do is to have other scientists, hopefully of goodwill, they may be skeptics, but fair players in it, to go out and go through these processes and see what they find. All right. And I think you'll start uncovering them throughout history. No one's looking because the evidence is subtle, but now the techniques are there and the tools are there. So
you might mention that up to this point, most of the investigations have been for literal craters, actual ground impacts rather than airbursts.
That's right. Exactly, Randall.
And without necessarily realizing that airbursts would be many times more frequent than actual ground impacts.
That's
especially
right.
Given what we now know about the census of the array of potential Earth impacting objects out there. It's the stuff on the lighter stuff, the lighter weight, which is actually the lower density stuff on that end of the spectrum is much more common. So the type of material forming Tunguska, much more common, the type of iron asteroids striking the Earth that, say, for example, created Meteor Crater in Arizona.
Exactly,
Randall. I mean, literally, it could be 10 times, 10
Yeah.
airbursts for every ground impact. Might not
That's
be
right.
Yeah.
That's right. And it all depends on what scale of airburst you're saying. When you see a shooting star, there was an airburst up there. It's a little one, and people just forget that there's a class between Meteor Crater and Chelyabinsk, which we've seen in our own lifetime. And that class is quite horrifying. And it's only one step up from Chelyabinsk.
And Chelyabinsk, to me, seems to be like this is sort of like the line of demarcation, the point where it's just a great visual event in the sky and something that can actually cause surface destruction.
That's right. When you talk about the change in density,
mm-hmm.
when I'm trying to explain this to people, I kind of find it helpful because I guess it's been a long time since I realized this, but I didn't understand it at first, or we didn't think about it this way. The change in density from outer space to atmosphere is an impact in itself.
Yes.
Right?
Absolutely.
It's orders of magnitude, a lot more dense atmosphere than space. So you kind of have two impacts. Mm-hmm. It's a little bit like somebody jumping off a bridge to commit suicide, if you will. They don't leave a crater on the bottom of the river. Right?
You get the water,
but it's highly destructive.
Yeah.
Right? Because you're changing density. Now you've got another level of density at the bottom of the river.
Mm-hmm.
And there are probably some instances, if you take if you shoot in the shallow end of the pool, you might make a crater. Right? But if you go in the deep end of the pool, you're going to raise some hell in the water on the way down, but you might not hit the drain at the bottom at 13 feet.
Mm-hmm.
And people just got to think we kind of have two different things that are impacted. And they would be far, far more frequent in the atmosphere. They would be on the scale of nuclear explosions or greater. Everything a nuke gives you, but without the radiation. And they would have left no evidence within a couple of hundred years that would be undetectable without a transmission electron microscope or EDS probe, whatever that thing is, or Raman probe, all these super tools that we have. But yeah, so you get that change in density, you're going to have horrific impacts. And of course, that was supported. There's so many, it's so great how the science come forth, because it's always surprising. You never know when you're going to get that new little nugget of info, that new paper, the new change, because there are people globally working on this. And a great example of support for this kind of thinking, you know, was the Orofino paper that y'all went over the other week on Cosmographia and in your report, supporting Bill Napier's lifetime of work, Klube and Napier et al. On the torrid stream, and that somebody went back and double checked his math. Not even double checked it, he added a whole new level of understanding to that class of objects. And as y'all know, it came up absolutely in support of the fact that there is enough material out there in proper orbits that we should expect, if Napier is right and the confirming paper by Orofino, I believe it is, et al. Is correct, in their subsequent rework of the data with new ways to look at it, if they're right about that, people are finding things out there, from Schultz to the YD group to Tankersley there, finding things that support that astronomical understanding that there's much more. There needs to be more geological work. There needs to be more work on both ends. It needs to be done by teams that have both kinds of people in them.